In today's video, we are going to be going through Intro to Symmetry. So I have two cases of symmetry here. I have reflective symmetry, and I have rotational. So with reflective, we are giving two lines of symmetry. We're given this purple line that's going diagonally across the coordinate plane, and then we're given some y x-intercept line right here. The way that the line of symmetry works is that you are going to reflect the shape across that line. So if I were to take this point, we're going to label this point A, and write that bigger, and take this point A, and I want to reflect it across this green line. So that's 8. So we're going to reflect this all the way across. We're going to go the same distance. This would now be that A prime. If I were to take this point, we'll put that as, do it like this. So A, B, C, D. And we'll actually make this a different color to make it more apparent. We're going to make this that green color. Yep, like so. So we said this was going to be A prime. It moves the same distance from the original point. B is now going, because B and D are on the line of symmetry, they are going to stay the same. So we'll actually overwrite that. B prime. Make this D prime. And then all that's left is C prime. So it looks like it's 6. And we go across here. This is going to be your C prime. And then we are going to match like so. Go here. A connects to B. And so in order for a shape to be defined as symmetrical, it needs to be unchanged about this line of symmetry. And so as you can see, the blue shape is not overlapping the outline of the green, therefore that this is not symmetrical about that green line. Now what if I were to reflect this across that purple line? Let's see what that would look like. And change this to be purple. Okay. Well, we're seeing that we're given about 3.5 diagonal lines. So we go 3.5 diagonal lines. A would end up right here. It's A prime. Same thing for D. A and D are essentially swapping. D prime. And then we look at B and C. We see that B has 1, 2, about 2.5. And it's the same thing for C. So these are also switching positions. B prime, C prime. If I were to draw the outline of the shape, I can make that a little neater. Now it's not the best, but you can see that it is overlapping the original shape. Therefore, that this shape is symmetrical about this line of symmetry. All right. So now that we've taken a look at reflective symmetry, now let's look at the rotational symmetry. Same thing applies with rotational symmetry. If it is rotating about a certain degree, it should look the same. So, and we're going to rotate it across the x-axis. I'm going to take a duplicate version of this. We're going to copy. I don't need the words, but all right, so here I have a copy of this shape. If I were to rotate this 90 degrees, you see that the shape isn't symmetrical, but if I turn it 180 degrees, it is symmetrical about the horizontal axis. We would say it is horizontal, it was symmetrical. Its rotational symmetry is 180 degrees. Because as you can see, at any other angle outside of 0 degrees, which is the original, and 180 degrees, there are no other angle in which the rotation occurs that would make it look symmetrical. All right. So I want you to take a minute, pause the video, and see if you can find the line of symmetry for this reflective symmetry, and then if this shape is symmetric, has rotational symmetry. All right, let's go over the answers. So here, and I should have made this apparent before I asked you guys to do the problem. This is the first line. The second line was the y-intercept. So the y-intercept. So let's go over y equal to x. If I were to reflect, and we'll take a couple points here. Four, 5. So here I'm given about one diagonal space. A, B, C, D, E. It should be somewhere around right here. B is about 1, 2, 3, 4, 5, 6. So we're going to go about 6 across. I'm going to go about 6 across. Should end up somewhere around here. And as you can already kind of tell, is that it's not going to overlap this star shape. So I mean, I could finish this, but for the sake of the video, I'm just going to draw where the dots should end up. Right? And really it should end up somewhere this way. Right, somewhere up there. This one should end up somewhere around here. And then this last one should end up somewhere close to here. And so if I were to draw the outline of that star shape, it would not overlap the original shape. Now, what if I were to supposed to reflect this across the y-intercept? A, B, C, D. Well, if I were to reflect this across the y-intercept, this C would stay the same. This A would move 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So A and E would switch. And let me put this in another color. We'll do red this time. So this would now be E prime. This would now be A prime. This would stay C prime. And then it looks like to me we're about 8.5 here and about 8.5 here. So B and D will also switch positions. And then if I were to draw the outline of this, not the neatest, but bear with me, it would overlap the shape. Therefore, this is reflective across the y-intercept. Now let's talk about the rotational symmetry of this ninja star here. I'm going to copy the shape, put them next to each other, and then let's see if there's any rotational symmetry outside of the original degree. So if I'm turning it 90 degrees, nope, turn it 180 degrees, turn it 270 degrees, and then back to 0 degrees. So there is no rotational symmetry for this shape.